Hello and welcome to another video. It's finally time to do some ballistic testing for the composite armour which will be laid into these casings for the powered armoured exoskeleton project. Now for the composition of this armour, I've really took inspiration from the Chobham tank armour, of which is a multi-layered composition of hard materials like ceramic followed by softer materials like polymers in their case. However, because I need my armour to go around curves, what I've gone for is hexagonal tiles, kind of like a honeycomb structure. That being for the hard outer layers, and then for the softer, more gummy layers, we have layers of Kevlar or other materials that we'll be looking at today. The idea of this is when a round hits the armour, it hits the harder ceramic. That takes a lot of the energy out of the round as it basically has to turn the ceramic to dust. And then the softer gummy layers in between help to hold some of the shrapnel and the remaining parts of the round in the armour before it passes on to the next layer of ceramic, and this chain basically continues until the bullet is stopped. Now this isn't the first time I've made this armour, and before we get into the test pieces that I've done in the past, I do feel like I need to do a bit of a disclaimer / also go over some of the UK gun laws to explain why I'm using some of the calibers that I'm using and why I'm doing the project in general. Which is where we'll start now. Of course, I clearly have a natural interest in all of this, but I was also actually trying to go down the official route with this project and get on actual military development programs, mainly at the Defence and Security Accelerator in the UK. However, even though the project in general seemed to be of interest to them, it became obvious that I was never going to get anywhere officially at this moment because I'm doing this on my own. I'm not funded, I'm not part of a big company. So while I do really enjoy doing YouTube, one of the reasons I'm also putting all of this on is to kind of gain status and notoriety for doing it, so one day I might actually be able to do something with it in an official capacity. Now quickly, a little rough overview on the gun laws in the UK. And this is a very short overview just for the purpose of this video. So you can have a shotgun license and a firearms license, shotgun being self-explanatory. The firearms license you have to apply for, get certified for, and everything like that. And in that you can have a semi-automatic 22 LR, and then everything above that in caliber is basically a single shot bolt gun. Another thing is places you can shoot like ranges, or if you're a farmer for example and have a firearms license for your farm, is that each place will be rated to shoot a certain caliber depending on how big it is, depending on the range, etc. So this can mean that people have quite random calibers of guns depending on where they can shoot. So they'll typically get the biggest caliber they can shoot in a certain place. This means you do end up having really random calibers, and one of the calibers that we'll be firing today is kind of because of that. So the choice of calibers we have today is 22 LR, the odd one out being 222, and then 7.62 in FMJ. 222 being the odd one out, it's nearly 5.56, but it's not quite, it's a little bit shy of that. But it should do well for this video. Also, when I've looked into the license before, I've seen something about a social media declaration. I don't really know what this is, and naturally, because I'm in the UK, I am going to play it safe on that, so there won't actually be any guns shown in this video, just to make sure there's no problems, especially as it wouldn't be my firearms license. So with that covered, we'll go over to the old test pieces of armour that I made quite a while ago. And here are my old test pieces. You can see they all have a thin layer of metal on top, whether it's either aluminium or steel. Kind of ended up as worthless really because they're only thin. I needed to keep weight down. So this is something I'm not bothering with in the future. So if we go over to this first test piece, which also shows how pointless the metal was. This didn't use ceramic, this used hexagon polycarbonate pieces, all cut on a CNC machine. And this did basically nothing, so you can see 5.56 pass through there, through the layers of Kevlar, into the other polycarbonate layers, which really went through there, sailed through those layers, and out of the back. As you can see, the metal on the front and back did absolutely nothing to stop it, didn't even really try. This is 3 layers of polycarbonate if I have it correct. Yep, there's another layer inside there. So that was a case of the polycarbonate was completely useless. Moving on to the other main piece, this one here. This has 2 holes, as you can see. One of them is 5.56 and one of them is 2.43. Again, those weird calibers that I was talking about is kind of thing that people have. 2.43 being a next down 308. So if we pull off this top layer of metal, You can see we've got a layer of ceramic tiling on the inside here, all of these hexagonal ceramic tiles. What this does mean, as you should be able to see here, is that it only damages either 1 or 3 tiles depending on where it hits. If it hits on one of the lines of the hexagons, then of course it'll damage 2 or 3 tiles. If it hits dead center of one of the hexagons, it will only damage 1 tile. As you can kind of see here compared to there where it's hit the corner of the tiles versus the middle. This has then gone through the bridging layer of the Kevlar, as you can see there, and then into the second layer of ceramic tiles, as you can see on this side. But if we bring over the last piece, what you can see here is you can see the 556, which has stopped at that last layer of Kevlar, which on the other side, you can see how it hasn't penetrated at all. It's completely flat on the back as well. However, you can see the 243 definitely made it through. I do also think it's quite interesting how it's made it through. It's followed the weave of the Kevlar on the front and back. But you can see how it's definitely blown all the way through there without issue at all. Now it comes to the last 2 plates. This is where I was surprised. So on this one, we have a thin layer of stainless steel on the front. It's like 1 mil thick. And then on the back, we have 2mm thick aluminium. And you should be able to see how it has deformed the plate on the back here, but it has kept it in. So what's the contents of this one? The contents of this is basically some scrap that I had laying around. So I still had some ceramic tiles left over. So I've got 2 layers of ceramic tiles there. And then some fiberglass on the back, just kind of as extra layers that I had laying around. And then of course the aluminium on the back. So you can see that did stop 556. Which I thought that was quite surprising. I didn't expect that to stop anything. But the more surprising one was this plate here. So this plate, thin layer of aluminium on top, again, did virtually nothing, although it is interesting to see how it burrs the top of the hole out compared to the steel. And then if we open it up, we've got 1 layer of ceramic under here, which you can see the round entered and blew through 2 tiles. We've then got another layer of aluminium that kind of acted as a thin gummy layer. You can see how it deformed the plate quite a lot there. And then this was, as you can see, literally just double-sided taped onto some polypropylene plastic, 9mm polypropylene plastic, and it just about stopped the bullet from coming through. It was only just, and it was interesting on how it actually deformed the back plate, but that was surprising to say that it actually stopped that. So the key takeaway with this was ceramic was the key to stopping the rounds. Ideally, some form of gummy layer on the back to help catch the shrapnel and the fragments of the round. But really the key thing was a decent ceramic layer or 2. While this testing proved surprisingly successful, which was very positive, one problem that I realized that I was going to have is basically finding a decent constant supply of these hexagonal ceramic tiles. For example, the tiles that I've used in these test pieces that we've just gone over was one from a local DIY store, of which those tiles were around 6mm thick, but the tiles that I was able to get in bulk for the last prototype weren't quite as thick when they turned up. They might have said 5mm in the ad, but frankly, if anything, they were down to 4mm, which a drop from 6mm to 5mm is quite a lot as a percentage. When you're talking 6mm to 4mm, that's a way bigger amount. Also, the general quality control of these tiles is unknown to me. They are meant to be decent quality porcelain tiles, which is the hardest type of ceramic that is natural. So for example, a lot of the armour ceramic that you see, whether that's either in tanks or in plate carriers, is something like a sintered silicon carbon boroid, if I remember that correctly. But for me, those tiles are pretty damn expensive. They're not that available in different sizes, and it's certainly not something I could make myself. So I am doing the natural ceramics, which porcelain is the best bet. Now, I was going to make my own tiles for this video, but then I realized I couldn't really decide on how thick the tiles wanted to be and how thick the in-between gummy layers wanted to be. So for this video, we're going to be making a couple little target pieces, but also using pieces from the old prototype, shooting those and seeing what happens with those thinner tiles that are fitted in that. Because I'm making my own custom tiles as well, I can choose the overall size and diameter. So if I decide I want them a little bit bigger than these, which these are all 23mm when they're done, I can do that. So if I wanted 6, 7, 8 mil thick tiles that are say 30, 40, 25 millimeters in diameter, I can do that. I can also use the highest grade of porcelain clay to do that with and make sure I've got full control of the quality control, if you will, of the process to make sure whatever test pieces I make will perform the same as the end armour. So one other thing that I want to trial for this video is I want to trial some different types of gummy layers, mainly because the price of Kevlar is absolutely extortionate. You're talking £30, probably like $35 a square metre per layer of Kevlar. So the bill for the Kevlar for this suit will be astronomical, as expected, as it was for the last prototype. But if I can use other materials, in which case at this point I'm thinking denim, then I can basically reduce the cost by 90%. And the thing is, while of course Kevlar is better, because I'm having to set all of this in resin so it all supports the fitting of the tiles and everything, the whole unterability of Kevlar kind of goes away at that point, because as a round penetrates the Kevlar, if it then cracks the epoxy, then the epoxy resin then cuts into the Kevlar and basically makes the whole unterability of Kevlar irrelevant. So now I've rambled on for long enough, we'll get making those other targets and then do a roundup of all the things we'll be shooting. Here we have the target casing. You can see we've got a nice target on the other side, so we'll start filling this up. For these test pieces, I'm going to use a mix of double-sided tape to lay into the bottom of here, or resin, like this Sodal Fix-All. That's so I can apply all of the tiles, like these, into the bottom of the casing, and then start layering up the denim after that. And while we're at this point, I'm going to take this moment to please ask you to like and subscribe. And I also have a question for you to answer in the comment section. I'm currently just using epoxy resin for this. I've got it from other projects and it works well as a date and point resin. However, I feel like I should be using some other type of resin, something a bit more gummy and softer, maybe a bit more rubbery. So if you have any suggestions for that, please comment down below on what resin you would think would be best for this gummy layer. I made 2 of these targets, one with 2 layers of ceramic, one with 1 layer of ceramic, to see what the difference would be. And as for weight wise, there's not actually that much in it because I built them all both up to the same thickness. So one's obviously got a lot more denim and epoxy, which I guess makes you think you're better off doing more ceramic than less, because you're not really saving much by getting rid of layers. We've also got this groin pad from the old prototype. It's got ceramic laced into these 2 parts here. Now if we turn it over, you can see I have actually took the ceramic out of the sides here to build some of the rest of the plates because I was running out. But you can see I've got the ceramic laced in underneath here, and this portion is overlapping, so you've got this ceramic laced into both pieces. I don't really expect this to stop that much because they're not that securely held in. However, I do want to see what happens if I add some denim to the back. So I'm going to be adding a load of pieces of denim to the back like that. However, what I want to do is I want to use a different type of resin, so not epoxy resin. So I'm going to try some Evo Stick Impact to stick all the sheets together. That should give me a bit of flexibility, and it should also be lighter. So we'll see what happens if anything breaks through the ceramic, which I imagine it will, and how it embeds into the denim, whether it penetrates it or not. And I did some absolutely incredible camera work here. But with those 10 layers bonded together, we'll bond that onto the back of the groin pad, and then it's ready to go. And here we have all of the pieces that we'll be testing today, including the targets that we've just made with the denim that I've roughly painted to make it a bit easier to shoot. And then we've also got a plate made up of pieces from the old prototype, this being a test piece for an early groin pad. This is 2 layers of ceramic with layers of Kevlar in between. And then we also have that groin pad from earlier as well, with the denim stuck to the back of it, with the ceramic tiles laced in the front. We've also got these 2 helmets here. You can see this one much more heavily armoured, way too heavy for reference. But I want to try get some glancing blows off of this and see what happens to the armour when it isn't a direct hit. And then this one is a lesser armoured helmet. It has good frontal armour but less armour on the side, so to try and test both of that, the frontal and the side armour on it, and also test the visor, which is 10mm polycarbonate, which isn't obviously going to stop very much, but I also want to see what happens when you actually strike it, whether it pops out, whether it damages, how it's actually held in because it's only bonded in with resin. I do, however, have 2 layers of 10mm polycarbonate fastened together to see what happens there. Again, I don't expect this to stop very much, but I'll be interested to see what happens. If there's time, and while I'm not that bothered about this at this point, if there's time, I do want to test this piece. This piece is literally just Kevlar on the back of here. This was some early back of the leg armour on the old prototype. So at the bottom, it doesn't have any ceramic. It'd be interesting to see if anything stops that at all. And then the main piece to get round to is this chest piece here. So the main piece of the arm that you can see here is 2 layers of ceramic with Kevlar sandwiched in between and backing it. It also has some foam on the back of it. However, what I really want to test this for is I've also added much more layers on the inside for this test. So I've got one of the arm pieces of the old prototype fastened to the back of this, and there is actually another piece sandwiched into the middle here, making up a total armour thicknesses of 6 layers of ceramic, each with layers of Kevlar in between them. So I like to think that this will stop 762x51, and I will be taking a block of clay that I've got to kind of press against this to try help hold it all together and have some backing for when the round hits it. Now all of those are gone over, we'll get these loaded up and go to the range and see what happens. To make the testing easier, I decided just to shoot them all at once, and then we'll go over all of them at the end. But as you can see, we started off with the target pieces we just made with the denim, and then moved on to the parts from the old prototype. Right now we're using 222, and as you can see, we're starting to have some problems with the ceramic. It's not really stopping a great deal. But I do find it quite interesting how it's blowing the ceramic dust out after it's passed through. Boom ting. And now for the 22LR. Well, that's got it now. This is the polycarbonate resting up against the clay, with 222 first and then 22LR. The sellotape didn't quite hold though. And now for the 762, which we had some problems with because it really wasn't sighted in at all. And we are trying to aim for that little blue piece of tape next to the orange strap, but it was shooting about a foot low, which is a bit problematic when you're only at 25 yards. But eventually, after many rounds, we did manage to hit that target. Perfect. And we are back from at least relatively successful testing. What to start with first, we'll go over with this thin layer of Kevlar from the back of the leg armour. This being just 5 layers of Kevlar, so really not very much. Didn't expect it to stop much, and it didn't stop 22 going all the way through. But it is a good reference to know what that actually does. Which to me, 22LR is like, if you stop 22LR, you're basically stopping shrapnel. But if it can't stop 22LR, there's a question of, is it worth even having whatever you put in there? So in this case, if it's a case of just having thin layers of set Kevlar in resin, probably not worth bothering. Then we'll look at the plastics. So the visor, this was quite a shock indeed. This did actually stop 22LR in 5mm of polycarbonate, which I did not expect. I thought this was going to sail straight through. But the round is still embedded in the visor. It has deformed the back quite a lot, which you should be able to see some of the deformation that I've put up now. By the way, the reason why it's got parcel tape on the front of the visor is because I've tried to 3D scan this helmet, and the scanning doesn't work if you see through the visor. But something that was also interesting is it didn't like ricochet the visor out of the helmet, which I thought it might do, because this is really just lightly glued in with silicone glue. Also, while we're here, we can look at the top of the helmet. So this being kind of a glancing shot of 22LR. It, as you can see, took away all of the ceramic on the outside, and some of it did go in to the layers of Kevlar underneath and ceramic. But with the angle it at, it did basically stop it. So at least the helmet is shrapnel proof in that case. And onto the other 2 pieces of polycarbonate. When these 2 put together was shot with 22LR, it of course didn't go through. It didn't go through the first layer, but the interesting thing is with that back layer on, it stopped the deformation in the back of the front layer. Of course, when it was shot with 222, it did go through, but it didn't actually sail through as much as I thought it would do, and it does appear to have actually resisted it quite a lot. It did make me think if you had a middle layer of actual hard glass, then it probably would have actually stopped the round coming through. Now we'll move on to the other helmet, and we'll highlight the issues with that ceramic tiling. So while there isn't as many layers of Kevlar in this, and this is basically all mounted onto a 3D print, so there's no inner layer of Kevlar, there's just foam padding on the inside. It really did not remotely try to stop 222, so you can see when it was side impacted, and this is 2 layers of ceramic, the round entered that side and then came out of the other side here. Which, if the ceramic tiling was the same tiles as I used on the other ones, you can imagine that that shouldn't have happened. And this is just where this quality of ceramic tile is coming in, where not only I don't think the ceramic tile is hard enough, but they're not thick enough. So I really do think I need to be making these tiles upwards of 7mm thick, really. If I can get away with doing any more, I might be better off doing that, because as we had this glancing shot with the 222 on the front here, that hasn't gone through, that has just embedded itself into the armour here. It didn't come out of the back, and it didn't go through the underneath into the helmet. Which kind of shows that the idea of the design, again, still does work. It's just that the ceramic isn't thick enough, because when the round is hitting the ceramic side on, essentially, it is thick enough to actually stop it, and it's just stopping it dead in the armour, like it did on the old test pieces. And this kind of set up the general theme for this ceramic and why I needed to do this testing to check this. So if we go onto those denim pieces that were made earlier, these being hit with both 222 and 762, and you can see how they all basically sailed through the other side. However, it's worth noting that the denim kind of looks very similar to what happens with the Kevlar, so I still think the denim could be something that's used in the future. I'm just not sure whether I use epoxy in the future. Also, this is the denim piece with 1 layer of ceramic into it, and if we compare it to the one with 2 layers of ceramic into it, it's kind of the same. Like, it didn't really make much of a better attempt at stopping anything coming through with 2 layers. So again, it's this ceramic that just isn't any good at all compared to the ceramic that I used in the past. But if we take a look at the other pieces with the Kevlar, and you can see how denim is still a possibility in the future. As if we look at the Kevlar ones, these really didn't fare any better. So again, when the ceramic isn't enough to snuff, it doesn't seem to matter what you have as the other layers. As for the chest plate, due to the other examples, I knew the chest plate on its own wasn't going to stop much, so I did decide to use whatever pieces of armour I could to back the back of this to thicken it up to see what it took to stop 762. We did have a slight comical problem though, is because that 762 really wasn't sighted in at all, like it was absolutely nowhere near. Kind of like some Demolition Ranch videos. So this just got absolutely littered with holes. Quite hard to track what is what and where it all went in and whether it actually hit armour at the other side or not. Which you can see if we turn it around, there is many a hole in here. What I was able to do at one point was prop up these denim pieces in the back here and then also tie this arm piece to the back in that regard. And testing it through this, what I found is it went through the chest plates, obviously, the 762 then went through both of these plates, but basically stopped on the surface of this plate. Now, this has got a secondary hole in it, because what we also did was then remove the chest plate entirely, try to target the pieces of these plates that were left undamaged, which I think it was that hole by the look of it. We then prop these up with this arm piece as the backing piece on the back, like so, and that is what made this big divot into this arm piece here. So if we're going closer, so if we look carefully here, you can see you've obviously got this big divot here, but then you've also got this mark there. That is the 762 mark from when we had the chest plate and the 2 pieces of denim targets with this back in it. So it just slightly marked it at the back here, at which point we took out the chest piece and just had the 2 denim targets with this arm piece back in it, and that is what did the big divot here. Which, to our surprise, it did actually stop. Only just, but it didn't quite make it through. You can see how it's pushed all of the Kevlar out here, but it hadn't actually made it all the way through. It is worth noting that that's quite a lot of extra Kevlar around those nut inserts you can see, so that's probably why it was able to hang on. This, to me, gives me hope of actually being able to stop 762 in the future, as this means it took about 5 layers of bad ceramic with a hell of a lot of Kevlar to stop it. So hopefully with some actual decent quality Kevlar, I'll be able to get this down to maybe 3 layers, which means at least the chest plate can be armoured to stop 762. And lastly, we have that groin pad. I didn't expect this to stop a great deal, but it about did really as good as I thought it was going to do. So when it came to 222, of course, it just sailed straight through the other side. But when it came to 22LR, it did actually just about stop it in the denim on the back. This being flexible with that Evo-Stick glue, it kind of just slitted the back of the denim, and it did actually stop any of the projectile from coming through. So I do think there is something to using more of a softer, gummier resin in the future, which I'll experiment on the next targets that I make. So with all of that gone through, what is next for the armour, at least on this project? Well, I think I'm going to increase the size of the tiles to 30mm in diameter. This is because if you look at things like this helmet here, the size of the damage, the portion, is a bit more than 23mm, a bit more than 25mm. I think if I make it 30mm, then that'll give me a good average of that singular tile absorbing the damage, not damaging other tiles at the same time, while still able to actually get the tiles to go around curves. I'm also going to chamfer some of the edges on the tiles so that it'll help it go around curves, which is easy to do when I'm 3D printing molds, pressing the clay into the molds and then having the molds professionally kiln fired to make sure the quality is good. I'm also going to thicken them up to, I think, 7mm thick. I've thought about going a bit thicker, but I want to keep the overall width of the armour to about 20mm. Including the 3D printed outer casing, which is 2mm, so that gives you 18mm to play with. If I go much thicker than 7mm, then it'll be difficult to get 2 layers of ceramic and some gummy material laced into it. I'm also going to shrink down the middle layer between the layers of ceramic just to say 2mm thick instead of 5mm thick, because I don't think it makes a difference. I think that is really just a layer to make sure that it keeps all of the tiles intact and in place, so that when the round goes through the first layer of ceramic, it's essentially hitting a completely new thing on the second layer of ceramic. Whereas if you have them touching, some of the energy might get transferred from the first layer to the second layer. Hope that makes sense. And then for that backing layer, that gummy layer, I want to try some different resins. I want to try some more rubbery resins that might allow a bit more expansion on the back. I think I'm still going to try denim. I actually don't think the quantity of the denim is that important now. I think it's more how gummy can we make this resin when it's set. So that's where we're going with the armour for the project in the future. But due to the amount of time that it will take to get those ceramic pieces made, put into targets and shot, the next video for the armour plating is likely to be 3 weeks. However, have no fear, as we have a new project for the channel. A project I'm pretty sure is going to have some armour plating put into it in the future, as well as an interesting and tasty drivetrain. So if you've enjoyed the video and any of this is of interest to you in the future, please like and subscribe. Thank you very much for watching, and last of all, I hope you have a great day.